we're able to apply the same technique we used when we scripted the particle behavior to follow a curve, but apply this to NURB surfaces. So in this case, we have the particles flowing to a UV coordinate and then progressively over the frames, traveling over the UVs, and in that way covering the entire surface of the geometry. And this is obviously a great technique for managing the flow of particles, such as a crowd traveling over an uneven surface dynamically, et cetera, et cetera. There's a lot of different applications, but let's just take a look at how this was done. So we can go into the p-type here and go into the event, and it's actually basically the same technique as was used for the curves, almost to a T. The thing is, here we're going along the X, which is basically representing the U coordinate. We could change that and also go along the Y. So what we're going to do is just copy this line here, paste that, and we also want to change the incrementing to also apply to the V coordinate. So we'll change this to UVWI dot Y, which represents the V coordinate, and we'll do the same down here. So the Y is equal to the Y coordinate plus 0.01. So in this case, what we should get is a kind of diagonal movement where the particle is streaming from 0, 0 and moving all the way to 1, 1, which is represented at this coordinate system. So you can see you can get some pretty interesting effects. You can see we're penetrating through a little bit. What we can do is just go to the goal and push that away from the surface a bit. There we go. We've also got the spring set quite high. We can bring that a bit lower. We can reduce the viscosity to get a different effect. So by changing these variables here, we can alter the behavior, obviously. So we'll increment by 0.08 on the V coordinate. So in this way, we're going off the diagonal slightly. And if we want to travel along the actual V coordinate and travel in this direction, let's just get rid of the actual U coordinate options and delete those. So we want to just adjust this increment here because we're a little bit too high there, 0.01. And there we go, we're traveling in the other direction along the surface. So there's a lot of different controls you can do to adjust the actual flow over the surface, but that's a look at controlling the particle behavior over NURB surfaces.